All right, our speaker tonight is Bob Breham, AK6R. He is the chief engineer at Palomar Engineering. They make plenty of unique balance and antenna products based out in California. And I'm not going to steal his thunder, so I'll turn him around so he can sort of see us. And I'll let him have the floor. Go ahead, Bob.
Okay, can everybody hear me?
Yeah. Yes, sir.
Okay, so let's get down here and share a screen with everybody. You need to turn sharing on, if you can, please. Okay, so let's go over here. Okay, now we should have a screen up there, and okay, you can now see. All right, so I'm Bob Breham, AK6R, Chief Engineer at Palomar Engineers, and one of the owners of the company, actually. And I'll give you a brief history of how that all came about 14 years ago. So tonight we're going to be talking about the magic of OCF antennas, off-center fed, multi-band antennas. In other words, how to get more bands out of the same amount of wire than you would with a normal dipole. And a little bit about coax noise filters, since most people don't know about those and how they work. And they've been a very, very popular item with us since we took over the company. And just want to let you know that they're available. And what they're used for, maybe you don't need it, maybe you do, but we'll have you find out if you do or not. So this website, this presentation will be up on the website tomorrow, and it'll be in PDF form, and it will also be in PowerPoint form, so that you can take a look at it just like you see it tonight. And if you have any questions, of course, give us a call, and we'll be glad to answer those. As well as there's a whole bunch of helpful technical guides that are for free download on our website. And one of those covers this topic. It's called the offcenter fed antenna magic, offcenter fed antenna confidence, right? And you're free to download that. I'll talk about that in just a few minutes anyway. So let's get started. And I'm going to tell you a little bit about who I am. I'm Bob Breham, AK6R. I was licensed first in 1963, a few years ago. I'm the chief engineer at Palomar Engineers, and we do a lot of the RFI and antenna systems for lots of hams all around the world. The company's been in business since 1965, and so just a few years after I got licensed, the company went into business. And we'll talk about that in a second. I'm a big contester. I work a lot of RTTY, FTA. I also run several nets on amplitude modulation, and one in particular called the vintage radio net, vintage signal sideband net, where the goal is you have to check in with the radio before, it was made before 1980. And it's a lot of fun to get to see all these old boat anchors that are actually running and stuff. So that's who I am. Let's talk a little bit about who Palomar Engineers is. It was founded in 1965 by Jack Aldous, A6NY. He passed away at the age of 92 in the end of 2013. And his two kids were CPAs. They knew nothing about radios, and the entire company had been put into a 10-foot by 10-foot storage area, and that's when we found it, so to speak. He was a neighbor about 20 miles away. I knew him real well, and Palomar Mountain was real close to us, so that's how the company got its name. And so we took, my wife and I bought the company, and we took it over, made it a woman-owned business, by the way. And our objective is to provide products that make radio communication more effective and more enjoyable. And we're doing it right. We use the right components, and we do things a little bit differently than everybody else. And as a result, we get better results by doing that. So, just a brief rundown of what we actually do. We do antenna systems, off-center fed antennas and we make them differently than everybody else, so you get more bands per buck. We make end feds, all different types of end feds, resident and non-resident, loop antennas, which are very quiet, and terminated folded dipoles. We provide all the components for those. Used a lot by ALE users. There's about 50,000 of those in the United States, so very popular item. We make balance on unsteelite chokes and coax noise filters. In fact, we created the concept of a coax noise filter back in '64, in 2014, I believe it was. And since then, it's been one of our top sellers. We provide our RFI solution kits for hands, households, marine, RV. We do a lot of things for the military, all kinds of stuff. We have ferrite core products. We're not going to talk about those too much tonight, but you're welcome to look at them if you have RFI issues or you need any types of rings, snap-ons, slip-ons for different applications. We also took over the publishing of the Kurt Sturba books. Kurt Sturba was a pseudonym for Jack Galthouse. And when he passed away, we got all the manuscripts from every book that he had written for CQ magazine. And so we took those and we made them as free technical downloads. And they're Elmer guides, a lot of humor in them, comedy, and other types of technical information, as well as comparison of different manufacturers and stuff. And so he wrote a monthly in CQ magazine for over 10 years. And so there's quite a bit of information that you'll find enjoyable reading, let's put it that way. We distribute our products through HRO, Gigaparts, Radio World, Direct, or eBay. And you're welcome to use any of those venues, buy from us direct or whatever. We, again, serve the amateur consumer, commercial, and military. But tonight, we're going to be talking about off-center fed antenna workshop. And so what we're going to specifically be talking about are a short overview of antennas in general and how you feed the different types of wire antennas. And that includes the dipole, off-center fed antennas, and end feds. And you'll see why I'm going to talk about end feds in a little while, because in fact all antennas are dipoles. And whether it just depends upon how they're configured. So we're going to show you some concepts you may not be familiar with, but they're really practical, particularly if you want to put a lot of bands in a small amount of space and still be very efficient. Popular OCF antennas include half waves and also end-fed off-center feds, which is something that we developed about 5 years ago and has proven to be very, very popular among the soda people, as well as people who live in smaller lots. We're going to talk about, show you typical configurations that work all the time for local and DX purposes, and how to choose an OCF antenna that fits your needs, which means bands, space, power, etc., etc. And then a little bit about feed line chokes, why they're so important with any antenna, not only OCFs, but all the different types, even beam antennas. A little bit about coax noise filter, and something probably you don't realize is antenna switches are the source of a tremendous amount of noise. And here's one way that we have to get rid of some of that. Then we'll end up with a few questions and answers. And if I was in front of you, we'd be awarding some prizes for the answers to the questions. So listen up, and we'll take questions at the end of the talk. It takes about 45 to 50 minutes to go through the talk. So put your thinking caps on, and let's talk about what we're going to be doing. And so one of the things we're going to talk about is why do some antennas work and some don't? I'm sure most of you have been through more than one antenna. And if not, make this your first antenna, you will never be disappointed. Hi. So we're going to talk a little bit about that, why they work and why they don't. And why does noise ruin good signals? All right. A lot of you have been on 10 meters or 20 meters, or even 8 meters during the day, and the noise is so bad you can't hear anything. And so there's a way to get rid of some of that, not just by pushing a button onto the radio, but by actually designing the antenna so you don't get the noise in the first place. And why does coax sometimes radiate? All right, you'll see a lot of manufacturers do this, and they don't tell you about it, but your coax is actually part of the antenna, whether you know it or not. So let's simplify what's really happening and point you in the right direction so you can decide whether these types of antennas are something you want to investigate. Okay, talk a little bit about feed point options. All right, and these are the different types of antenna that are most common among all of us. There's the center fed dipole. You put up a 40-meter dipole, and the impedance will vary depending upon the height of it. And you're feeding it right in the middle, right? And typically it's going to be roughly 50 to 100 ohms in most cases, if it's up about a quarter wavelength or so. The off-center fed dipole is a little different. And to put it in perspective, the center of the dipole impedance is roughly about 100 ohms, 50 to 100 ohms. And the end of the dipole, all the way out to the other end, is roughly between 2,000 and 3,000 ohms. So somewhere between the end and the center, you're going to find a place which is roughly 200 ohms. And that's what we use to match an off-center fed dipole. So we choose that position in order to design our products. The non-resonant antennas, which means like end-fed long wires, which are not a multiple of a half wavelength or a quarter wavelength. For example, 70 feet, which is a little bit bigger than 40, a little bit less than 80 meters. That's a non-resonant one. And their impedance is roughly 400 to 600 ohms. And so we use a 9-to-1 transformer to match those. All right. The resonant end-fed halfways, which are very popular right now, and fortunately they have a lot of negatives to them as well as positives, are roughly 2,000 to 3,000 ohms. And they use 50 to 1, 49 to 1 transformers, which unfortunately are very small bandwidths. And then we have the resonant and fed off-center fed, which is an off-center fed antenna, like we'll be talking about tonight, but it only has one wire to it. And it uses the coax to disguise itself as the other antenna. Very, very interesting antenna. All right, so each one of these needs a different transformer to match it, right, to the impedance, right? So let's go and look at a typical, in this case, it's a 40-meter antenna, and it'll point out a couple of things that you may not know about the antennas. I'm sure most of you are familiar with the Dipole. It's a small antenna. It's found about 6 to 8 feet over the ground on a tripod, and it's used by a lot of the Bucks on the Air, Summits on the Air, and those types of applications with low power, typically 10 to 100 watts. Well, when you take a dipole and you take it down that close to the ground, what happens is it becomes a very low impedance speed point in the middle, right? But as we had mentioned before, if you move that middle off a little bit from the center, the impedance will go up. So what they do is they make an antenna which has the same physical length, but it's not fed in the exact center because they put a little coil in it so that electrically it's off-center, mechanically it's on-center. And by doing that, it matches very close to 50 ohms. And it's a trick that they play. Most people don't know that, but it works very well. Well, we can do that same thing with any type of dipole, no matter what the frequency is, and it will work exactly the same way. So our goal here is going to be how do we maximize a length of wire to fit as many bands as possible so you can have fun as much as you can. So one of the things that you have to learn or experience before you choose what kind of antenna is, what's a good installation? How do you put these things up, and what makes a good installation? A good installation is one with a choke at the feed point. We'll talk about why in a couple more slides. Well, the coax drops down about 90 degrees from the antenna. So if you can imagine the dipole stretched straight out horizontally, the coax would go right down towards the bottom, perpendicular to the antenna itself. A lot of antennas are slopers, a lot of antennas are inverted V's, but still the coax goes down pretty much directly to the ground. The antenna should be high and clear. It shouldn't have a lot of metal around it, for example. A poor installation is one that has no choke. Well, when you have no choke, you really have a tripole, and we'll talk about that specifically later too. No choke, so the coax braid becomes part of the antenna, whether you like it or not. And as you change the length of the coax, your antenna will tune differently. All right? Even though you haven't changed the actual wire in the antenna, it will tune differently. Sometimes good, and sometimes not. This is good. All right? And if you have the coax running along the antenna, or very close to it, for example, straight off the side, and it's at a 45-degree angle to the wire, it will start coupling into the antenna, and it will tune completely different. The other thing we talked about is a low installation. All right? Like the Dipoles example. When it's real low like that, the impedance changes on the antenna, and as long as you're aware of it, or you put a transformer in there that transfers the energy, you'll be in good condition. Okay, so what is an off-center fed antenna? What's the definition of one? Well, we have found that depending upon the bandwidth, and we make antennas from 160 to 6 meters all the way down to 20 to 6 meters, depending upon the length that you want and what you're using it for. The 20 through 6 ones, for example, are used a lot by the parks on the air people because they're small and they can put them up low and they still work just fine, and you can work multiple bands with a smaller coax. We found that depending upon the band range that you're going to be working, either 20%, 80% of the short wire to long wire, or 71-29, 79-21 are the best ones to choose from. Now I'll tell you, most other manufacturers do not use those ratios. They use the 34%, 66% ratio. And that's the most popular. You'll see it, everybody's selling that. Unfortunately, they're using it to design way back when, before 15 meters was actually a legal band. And they're still using it because all they're doing is copying. They're not providing any new engineering to make it work. And you lose the band for 15 meters. There's no way you can work 15 meters and have such a high SWR. So we wanted to get around that. We wanted to give you 15 meters. And as well as that, we give you 6 meters too. And none of the competition does that either. So you get more bang for the buck in the same amount of space. An off-center fed antenna, of course, is fed differently, so the current and the impedance are different than a regular dipole. All right? And you can access multiple harmonics for more bands with the same amount of wire. And guess what? There's no traps or coils, no lossy traps or coils to take up energy that you would normally have. Whenever you use a coil, it typically is a compromise, and as a result, you don't get as much amplification as you do without it. One wire, many bands, more bang for your buck. That's what we're aiming for, and that's what we provide. Okay, here's a little slide that I'm explaining. I've been to a lot of hamfests and things. I have 300 or 400 people in a room, for example, that we're giving a talk to. And I asked a real simple question. I said, how many conductors does coax have? And raise your hand if you think it's got 2. And you know what? About half of the people will raise their hand and say it's got 2. But you know what? It's got 3. And most people don't understand that. But that third wire is what makes these antennas work or not work. All right? So let me take you through a little explanation here. We'll spend a couple minutes on this slide. As most of you know, there's a center conductor. And this is a typical dipole where the center conductor is connected to one side. And the coax shield is connected to the other. But now, if you look internally, what happens is you have electrical current either coming or going from the spinner, depending upon the cycle, as well as coming from the transmitter on the inside of the coax. And what I'm going to tell you is the inside of the coax braid, it's all the same piece of metal, is a completely different conductor than the outside of the same braid. That's a separate conductor altogether. So here's what happens. You're forcing current up through the inside of the braid, and it gets here where it's going to be connected to the antenna. And so it says, well, I got an exit in the highway here. I can go to the antenna, or I can continue on to the antenna, or I can go back down the outside because there's no stop sign here. Right? And so what normally happens is, and it splits the impedances from an engineering standpoint. What happens is that most of the current goes out here, perhaps 80, maybe 90% if you're lucky. And the rest of the current goes on the outside. It goes right back down here, right? That's a major source of radio frequency interference because it's going right back to your shaft, all right? Our goal is to get rid of that it's called common mode current. And our goal is to get rid of that current and stop it. And the way you stop it is with the choke right here at the feed point. That's the offside current that keeps everything on the antenna. And that's exactly what you do. And if you think about it, with an off-center fed antenna, it's completely unbalanced. Unlike a dipole where the sides are equal, right? It's pretty much shared in terms of the electrical current that's coming through the antenna. Well, with an off-center fed dipole, it's not. Right? If you're 80-20 or 71-29, for example, short wire to long wire, okay, it's very unbalanced. And because it's unbalanced, it tries to become balanced. And it does that by putting more common mode current back to the radio. It wants to see them both electrically the same. And so you need to put a choke in there to stop that. And when you do that, if the choke is big enough, all right, at the frequency that you're using it at, all the current will stay on the antenna. And you'll see later, and this is true of beam antennas, it's true of all different types of antennas, not necessarily off-center beds, which are a little harder because they are really unbalanced mechanically and electrically. Right? We use this technique with a lot of different types of antennas. There's different ways to implement it, which we'll see in just a minute. Okay, so how do we match the OCF antenna to a coax piece of cable, right? And there are two ways to do that, and it depends upon the type of antenna. If it's a wire antenna, typically you're going to use a balun. And a balun is a device with a transformer in it, 4-to-1 or 6-to-1 or 9-to-1, whatever it is for the particular antenna. And what it does is it splits the current into two different positions, a left and a right, for example, short wire, long wire, or something to that effect. If it's an unun, it only splits it to one, right? And so a vertical, for example, would use an unbalanced to unbalanced. That's what unun stands for. Balun stands for balanced to unbalanced. Coax is unbalanced, right? But a dipole is balanced, and whether it be off-center fed or not. And a vertical is unbalanced, right? It doesn't have to be vertical, by the way. It can be just a single wire that's horizontal. It doesn't. Electrically, you can't tell the difference. So two-wire dipoles typically will use a 4-to-1 balun to match them because their impedance, depending upon the height, right? And this is true of all the bands that they're good for, is typically between 100 and 400 ohms, right? So we want to choose a balun that usually makes the antenna have an SWR less than 2-to-1. So their radios are happy and they radiate, and we don't get a lot of radiation on the coax system, right? And in particular, we use 4-to-1 transformers, and we also include a 1-to-1 choke in the same box. We call that a hybrid transformer. Okay? Give you a little bit of background on the company. We started out in the RFI business, and then we started using the application of ferrets, completely different than anybody else uses. And what that means is we don't use toroids or round circles of ferrite in any of our transformers. We use beads, just like the linear amplifiers do in their final output stages. And the reason is because we have a much wider bandwidth and a lot less weight, and also more power for the same amount of space. And that's how we make everything. And as a result of that, we became very, very good at creating a balance, and items, by the way, that are very low SWR from less than a megahertz all the way past 70 megahertz. They're virtually not quite flat, but they're very close to it in terms of SWR. And our goal was to make sure they're under 2 to 1 in the frequency range that we spec them for. Well, nobody else does that. They all stop at 31 megahertz, so they stop at before 6 meters. Well, we got so good at those, people kept asking us, well, why don't you create an antenna based upon what you're doing? Because your balance are so good, there's such little loss in them. So guess what? We got into the antenna business about 5 years ago. And now, over half of our sales are antennas. And we've sold at least 10,000 antennas, all different types. And they're very popular, and they seem to work well for everybody. That's all I use here is wire antennas. And I use the 160 meter off-center fence, and I'm king of the band running 100 watts on those things. You're going to put money into a station, by the way, put it into the antenna first. A fancy radio from the poor antenna doesn't do as well as a dummy radio or a less expensive radio and a great antenna system. You'll have all the difference in the world. All right, so we're going to talk a little bit about what the connections are, how you feed these things, and specific examples of how you would do it in your station. We have power ratings from 100, 500, 1,500, 5,000 watts to match the output of your station. And by the way, I should mention that a 1,500 watt transformer for us will run over 1,000 watts of FT8. And most other companies, the old MFJ, for example, would run over 200 watts FT8 into their 1,500 times. And the reason is because they did it the old way, and they were going for single sideband PDP rather than digital PDP. Well, I was an RTTY World Contester back in about 2000, won a lot of awards and stuff, and I love high-duty cycle products. And so what we did is we designed all of ours so that you can run digital modes on those things and be confident that you'll get the output that you desire, as long as you have a good load on it. All right? You take one of our balance and you put it on a crummy antenna that you designed, or it has got the wrong lights and stuff on it. The SWR will be high. You're going to have to derate it for different SWRs, particularly high ones. They will not put out 100%. Okay, so let's look at some examples here. Here's some hybrid balance that we use in our off-center fence. And by the way, they're also used in looping antennas and some other ones too. Very, very useful. So we have the small on the bottom here, the 100 wattage, used by people who have apartments and smaller, or only running 100 watts. Well, they want to use the small off-center beds, which are only 20 feet long on one side, and they work just for 26, for example. On the other hand, if you're running more power, you're running a small linear, and you're running 500 watts, you might get this size. You can also get a larger one in a tube like this. We also sell the 1,500 in a box like this too. Some people like the boxes versus the tubes, but we seem to be just as popular. And we make them in a 5 kW one. We only make it in the box because it takes up a lot of real estate inside in terms of what we actually put in there. So why do we use hybrids, right? We use first of all, why do we use affordable and balance? And the answer is simple. We have our off-center fence typically have at high peaks, typically around 200 to 400 ohms, because of where we feed them. All right? And And that's, like I say, 20%, 80% for a short wire to long wire, for example. They transform the 50 ohms and they control the current. By doing that, the transfer of energy is very, very good between coax and the antenna itself. And that's what you want, high efficiency. That improves the signal quality on receive as well as transmit. In addition, if you include the one-to-one choke, either in the same box or if you just have a 4-to-1 valve, you can put a choke right underneath it, and we have products to do that if you need it. If you include the one-to-one choke, it keeps all the RF on the antenna and off the coax braid. I'll tell you, there are a lot of offset fed antenna manufacturers who only give you a 4-to-1. And in fact, their antennas will not work if you do put a choke on them, right? And the reason is they want the coax to be part of the antenna in order for the to keep their costs down, their costs up, for example, but also because they want to have smaller matching transformers. But I will tell you right now, a one-to-one choke is one of the better investments you can make on your existing transformers, on your existing antennas, or even on this one here, because it does improve the signal quality very, very much. Not all valves are equal. When you buy a valve, if you're just buying a valve, look at the specs, see what the bandwidth is, and see what the typical SWRs are over a particular frequency range. Right? They may be great from 80 meters to 10 meters, but they're terrible at 160 and they're terrible at 6. All right? We produce SWR graphs for every one of our valves on the website. You can see exactly what you're getting and what to expect. Okay, let's do a few typical installations and look at what one looks like. You usually need about 30 feet or more. Right? The higher the better as usual, and the end should be over 15 feet. Otherwise, you get coupling to the earth and they tune a little bit differently. You should have a wide angle between the legs. Right? It'll be 180 degrees, 145 degrees, something like that if it's an inverted V. And keep them away from metal roofs, fences, and solar panels in particular. I had one guy call me the other day and he had an antenna 4 feet above his solar panels. And he couldn't figure out why the SWR would never go below 3 to 1. And so we had to move it to one of his trees on the side of the property. And guess what? Everything returned to normal. So it was being decoupled into the solar panels, and they were acting as a large capacitor, changing the frequency of the antenna. A typical configuration. I'm going to use the 80 meter one, although the 40 through 6 meter one is our most popular. Most of us, at least when I get to my age, are always on 80 meters at nighttime, and a lot of us use this. So here's a typical 80 meter antenna. Right? And usually it's about 135, 136 feet long. Right? But ours, I'm going to show you, follow the mouse here. Ours are 38 feet on one side. We have our hybrid transformer in the middle. And then we have 27 feet behind a little mystery device here called a resonance compensator. And I'll tell you what that works for in the next couple slides. And then we have 65 feet here. So we have 93 feet total and 38 feet, right? 2 wires. And that's roughly 80-20, 80%, 20% in terms of, I'm sorry, it's 71%, 29%. And that's how it works. The coax comes out of the hybrid and then it goes down here to the station. Right? And we'll talk a little bit about coax noise filters in a few slides too, in order to get rid of some of the receive problems. Whereas the choke up here gets rid of the transmit problems, you still got receive problems down here because of that outside braid. But it's very easy to determine whether you have it or not and whether this will help. All right. So let's look at the SWR, these typical things. Why does SWR matter? Right? We aim for SWR always below 3-to-1 for all the bands. Typically, because, and the reason for that is because if you're just running barefoot and you don't have a external antenna tuner, most of the rigs these days, at least the common ones, with antenna tuners built in, will do 3-to-1 or less. They'll take a higher SWR and they'll make it 1-to-1. It'll make your radio happy. The antenna doesn't change, it changes the peaks at the end of the coax. So generally, most of our antennas are less than 2-to-1. And when you buy an antenna from us, we publish all the SWRs for all the bands that we've experienced. And we tell you how high they are, how much coax, all that type of thing. So you can say, well, gee, mine's about like that, and therefore it'll probably be a similar SWR. And at least you can see what to expect. You want stability, you don't want SWRs that change. Some of the things that NFJ used to run into is if you're running FTA on that 1500 watt valve, and it starts sticking, and you're running 600 or 700 watts, which is too high for FTA, but that's another discussion. If you do that, the darn thing will start changing, and it will saturate, and suddenly your SWR goes to kingdom come, because there's so much heat in the valve itself, right? And that was the real problem that they had, and that's why they created digital down to about 10% from whatever the size of the one was. Well, we don't do that. We specifically tell you how much you can run as long as the SWR is within a certain range. That's not a performance score. A SWR doesn't mean you're going to work more DX. It certainly helps in order to match the antenna. Use it as a diagnostic tool. Right? If you move the antenna from one position, for example, the guy with the solar, he moves into another position, all the SWRs are much better, and that's the place it should be, next to the solar. All bands can be worked, but none are perfect, right? Your antenna tuner can usually make your rig happy to hear and work all stations. And the analogy that I usually give is, everybody gets on, all the bands get on the bus, but nobody gets the front seat. So nobody's optimal, but guess what? Everybody's on the bus. Well, in other words, you get all the bands, but you're not optimal for any particular one. And I would rather have that. I would rather have an extra couple bands that I can operate rather than not having those bands at all. So that's that. So a typical SWR would be, this is the 80 meter one that we just showed you. All right. And so we sweep it from, in this case, we swept it from 1 megahertz all the way up to 31. And we have a little side one here on 6 meters. This is the SWR equals 2 line. This is the SWR equals 3 line up here. So certainly on 80 meters, for example, all right, it's nice and low. It's 1.5. On 60, it's a little high. 60 meters is up here at 3. It's usable with the tuner, but generally not a lot of people at 60, so they don't use that. On the other hand, 40 meters is nice and low. 30 is about 2.2, 2.3. And understand that an SWR 2-to-1 means you're losing 4% of your power. That's it. All right, so it's certainly acceptable to use it even without a tuner, as long as your radio or your linear is happy with that particular SWR. Sometimes they are, sometimes they aren't. Depends on the brand. 20 meters and 20 meters is down here. 17 is way down. So it's 15, 12, anything above 20 meters is certainly less than 2-to-1. Right? So in a lot of cases, you don't even need to touch the tuner. It'll be just fine where it is. So that's our typical 80 through 6 meter antenna. And they work very, very well. And like I say, it's one of our more popular ones. And this was all measured with 150 feet of coax, about 30 feet high. Because that's what most people could run, about 30 feet. And it's even higher than the SWRs go lower. So that's the advantage. Now, I'm going to introduce you to a new type of off-center FET. And if you remember, on this particular one here, we go back a couple slides. We had 2 wires. We had a wire at 93, and we had a wire at 38. This new type of off-center bed does not require the second wire, the second short wire. It only requires the first wire in 93. Instead of that, we're going to use the outside braid of the coax, 38 feet, to simulate electrically the exact same antenna. Right? So down here, let's see, strip down. We have what we call it the bullet because it's one of the things that our antennas are called. They're called bullets. This one's 80 through 6 meters. Again, 100 watts, 500 watts, 1500 watts. Right? We also make these in 20 through 6, 40 through 6, and also 80 through 6. Right? And there's a couple different models of each one, obviously. So what's the configuration look like? All right. Here's a diagram of what they look like. Remember, we had 93 feet here total. In this case, the 93 feet can be a sloper up or down. It can go, we got horizontal 90 degrees if you want, partway through it. That's what I do. I go out about, I guess it's about 50 feet. And then I have to go 90 degrees because that's where my next tree is. And it's still forgiving, it works just fine. But what I'm able to do is, I'm able to take the choke out of here, right? And I'm able to move that choke down here to the 38-foot position. So electrically, it looks just like an off-center thing. Got 93 feet here, it's using the outside of the coax down to the 38 feet, and it has a very, very similar SDR to the one that has 2 wires. Some people like to use this for a lot of reasons. One is, it only takes 2 supports now rather than 3. Right? So it takes less space to do that. A lot of homeowners use this. I even have folks that run this along the top of their fences, right? Or behind their gutters, for example. They tend to hide it from the homeowners associations. We use an ultra broadband 4 to 1. In this case, there's not 2 wires, so we use an unbalanced for a balance, and then the rest of it goes down coax. So we use an in this case, not a hybrid. We put the choke down on the coax. It's safe. It's got low voltage, and it has good current flow. The coax is part of the antenna, and so it radiates just like the wire does. So you don't want to take this down and wrap it all up because it's part of the dipole. You want to stretch it out, and if you have to, in my case, I take this out and I stretch it diagonally over here. And so it almost looks like a dipole, but it's much lower on this end than it is on the other end. And again, some bands may require a tuner, but you can run it in all different types of configurations, and it's a very friendly, very forgiving antenna. So what does its SWR look like? Well, gee, here's an example of what it looks like. And this looks very, very similar. It's a little bit different, but very similar to the 2-wire one. Right? It works on 8 meters here, 16, 30. These are all very similar to what we saw on the other one. So you don't lose anything from that standpoint. And guess what? You get 15 meters. Unlike all the other people that make these things, they're 15 meters as an SWR 3 to 1, 4 to 1, 5 to 1, right? Because they chose the wrong percentages for long wire and short wire. And in fact, nobody makes this antenna at all that I know of as a 1-wire antenna. It's really just another disguised off-center fed antenna. Once you understand that, it's real easy to make them work in a lot less space. You can now fit these in a 100-foot lot. You can zigzag it horizontally. It's a very forgiving antenna. You go from one tree to the next tree. It can be an 90-degree bend. They can go up, they can go down, and they still have that much nicer SWR curves, much nicer radiation. So, multiple advantages to using that. So, Now, we talked a little bit about the different antennas. Let's talk a little bit about noise on antennas in general, but also on offset beds. So, where does this noise come from? Noise in general on your antennas comes from switching power supplies, LED lighting, electronics in your home, solar panels, wall warts. There's a million things that they come from. And the best way to stop noise in general is to stop it at the source. For example, if you've got 50 wall warts plugged into your wall, guess what? If they're noisy, it's usually cheap, under $10, and they don't have a lot of filtering in them. And the filtering, because of that, they feed back their noise into your AC power lines, which is then radiated, and guess what? Your antenna picks it up, or the outside coax, the third conductor, picks it up. So what we want to do is see if we can eliminate that. And the best way to do it is eliminate it at the source. If you can't do that, for example, you have a neighbor that runs an arc welding machine at night, or has solar panels like I do, then you can't use the antenna that's close to that source. Right? I have 16 antennas here, and so I use them in all different places. I don't use the ones that are next to my neighbor with solar during the day. I use it at nighttime and try to 80-meter nets, but not during the day. So it's just a matter of making sure that we're not close to it, because there's nothing I can do about that on solar noise in this case. Okay, so how do we reduce this noise? One of the ways to do it, there's several steps that you need to take. Make sure you always have a choke at the antenna feed point, so that you're not getting RF back down the coax, which then goes right into your radio or your station and causes some of the noise. So you've got to stop it at the source. Something where the source is the dipole feed, or the beam feed, or the OCF, or the loop, or whatever it is. You got to make sure you stop it there, and that's when you're transmitting. The other thing that you can do is you put a common mode noise filter at the radio, at the entrance to your station. Right? That isolates the feed line, or isolate the feed lines with a separate signal enough. And we'll talk about that in a second. When we talk about the problems of antenna switches, which everybody has that problem. Lower noise means more DS, right? So I'm going to teach you right now a simple way to determine whether you have this type of noise, right? So, and this is on receive, by the way. And so, if you think about it, a piece of coax has 3 conductors on it. So what I want you to do is to do a band. You've got to do this on each band because it may be different. Tune to a band and unplug your coax 100%. Just unplug it from that particular radio. And see if all the noise goes down to 0 or S1. Very, very low. If it's not low, it's coming in through another wire. It might be your switching power supply. It might be your USB to the computer or something else. It might be a push-to-talk line to your linear amplifier or something like that. And if that's the case, you got to take care of that first before you take care of the coax. Right? So let's assume you don't have that. This make the assumption that you don't have it. If you do have it, we make kits for all the different types of radios, or we make a generic kit that you can use on any radio. Okay? We do it by brand, so you can look up an ICOM 7300, for example, and get a kit for that. Okay? So here's what you do. You take that piece of coax, and you roll back the outside connector. You're going to roll back this outside connector here, and only put in the center conductor. And now measure what the noise level is. And let's hypothetically say it's S2 or S3. Let's just choose S3. All right? Now what I want you to do is I want you to screw in the outside of the coax. In other words, put in the second antenna. The second antenna is the outside braid. Right? When you screw that in, if it goes from S3 to S6, for example, you've got common mode noise. In other words, you've got a signal picked up by the outside of the coax feeding into the radio. Okay? And so that you can get rid of. You can't get rid of the noise that's coming down the center unless you move the antenna away from the noise, you point it in a different direction, or you somehow stop the noise at the source. Those are the only things that you can do. It's always going to come down the center, not after the dipole, no matter whether it's a dipole or a beam or whatever. Right? But you can get rid of the noise that's on the outside of the coax, and that's called common mode noise. And that's what we specialize in. Okay. So what's a common mode noise filter, and what does it look like? Okay. So here's a graph of a couple of things. One is this is the amount of dB that are stopped for common mode noise over a frequency in the range of this is 1 to 61 megahertz. And the max is 38 dB. It averages about 30 dB throughout the entire range. Well, what does that mean in terms of S units? Well, each S unit theoretically is 60 dB. So 30 dB would be 5 S units. So you can expect that coax connector, or that coax noise filter, to reduce your common mode noise 5 S units. If it went from S3 to S6, when you screw in the outside brake, guess what? It'll go down to S3 and you won't have any. You just picked up 3 S units of signal that you can copy in. All right? Some of the larger noise filters that we have more ferrites in them, and then also are good for higher powers. All right? This one on the right-hand side is 1.5 kilowatts, and it averages about 35 to about 40 dB. Well, divide that by 6, you've got 7 S units, 6 to 7 S units that it goes in. And we make these in 500, 1500, 3000, and 500,000. And very good. By the way, we buy chokes. We provide these curves with these types of curves with every one of our noise filters. Nobody else does that. So when you buy a choke with 1-to-1, they don't tell you, well, how good is it? They just tell you, oh, it covers 1 to 30 megahertz, and it's a balance, or it's a choke. Right? But you have no idea whether it's any good or not. It's like buying a resistor without color codes on it. And saying, oh yeah, it's a resistor, but I have no idea what the value is, and whether it's going to work in my frequency range or not. Right? It's very, very difficult. So if you're going to look at chokes, make sure they have specs on it, similar to how effective they are. We do that with every one of ours. Right? And for those of you who are concerned about lightning or wind static, we have a product here. You can see it in the lower right-hand corner. And it's got a little stud on it. And when I used to talk to Art Bell, Bob Heil, and Joe Walsh on 80 meters all the time before Art Bell passed away. And Art Bell had 2 1,700-foot loop antennas, 70 feet at the top and about 30 feet at the bottom for his. And he told me, Bob, I said, I've got a real problem here. I've got a product that solved the problem. I had to do it. He had to do it himself. And what's happening was he had an FT9000, he used to FT9000, and he would get wind static of almost 100 volts on his loop antenna. And if he had it hooked to his, whether he was there or not, if he had it hooked to his radio, it would blow out the front end. And after this happening 2 or 3 times, and having to pay Dave to fix it, he said, I'm going to come up with a solution. We call that solution a static bleed. What it is essentially is a large resistor that bleeds off the center conductor, the ground. Right? So you hook it to a ground system, and it takes and always bleeds off that 100 volts down to less than a volt at any one time. Therefore, you don't have that problem. It's a very, very useful item. You can make them yourselves. You can buy them on a coax connector from us, or you can buy it built into some of these noise filters and some of our balance at the same time. So just a heads up, if you got that type of noise, it's the kid here with the problem. Okay, let me spend a couple minutes here on antenna switches. All right. I was speaking at Dayton about 2 years ago, and I was invited by Flex Radio to be there Friday at guest speaker. We had 950 people in the room, and I gave this talk because we do a lot of Flex radios. I'm a Flex radio man too. But we gave this talk, and one of the things I brought out was, do you know what the problem with antenna switches are? And the problem with antenna switches, if you get to the little diagram, every antenna switch should have a choke up here, the green one, in order to make sure that your transmit RF stays on the antenna. However, all the way back to your antenna switch, remember you've got an antenna, you've got two antennas, the center conductor and the outer conductor. And most antenna switches only switch the center conductors. They do not switch the outer conductors. So guess what? You may have selected antenna number 1 here, but you know how many, and let's assume there's no filter. If you selected antenna number 1, guess how many antennas you have at any one time? You have the center of that one, you have the outer braid of that one, and you have the outer braid of the second and third antennas. They're all connected into that antenna switch. So, an example would be my solar guy next door, and I'm using an antenna that's in the back 40, right? However, and I'm not even close to him, I'm not selecting that solar antenna, but guess what? I was receiving his noise because it was going to the coax that was hooked to the antenna that was next to his house. So I came up with the idea, I said, you know what? Let's isolate all these coaxes before they get to the antenna switch. And here's an example up here at the top. Here's a typical two antennas. So we put, in this case, we're running low power. So these are 500 watts apiece. Two different antennas. We put those through the noise filters before they get to here. So it isolates the braid here and here. So it doesn't make any difference whether these are isolated or not. It's not going to see, if you're selecting antenna number 1, it will not see the antenna current on the braid on antenna number 2. If you don't do that, it sees it. And so if you select switch number 1 over here, you've actually got 1, 2, 3 antennas at any one time. It can be a problem, it may not be a problem. And the only way to find that out is to test it. Do the same little test that we did on the transceiver. Right? Here's an example right below it. This is a flex antenna switch. And it's got 8 antennas on it, and actually 2 antennas. Because I run SO2R one time. So here's all 8 of them. And so if I'm using any one particular antenna, I've got 9 antennas at one time that I'm listening to. So what did I do? I put the 3,000 watt chokes, because I run high power. I put the 3,000 watt chokes on every one of these, except one, because that's my dummy load. I put the choke on every one of these, and guess what? All my noise went away. All my noise from the solar panels, from everything else disappeared. It went down by 6 to 9 S units. And it was just amazing the difference. Right? So a little FYI, make that test and see if it's a problem with you. May or may not, but if you do the test, at least you're aware it's a potential. Right? So before common mode advantages, before you may have a high noise level, it may be difficult to copy signals. After you put in the noise filters, it's reduced background noise in particular, where you have multiple S unit drop, and they have clearer signals or DX. We sell over 500 of those a month. They are just so popular. They're on a lot of YouTube sites. A lot of people have sworn by them, and there's multiple testimonies. So it's a good thing to know about. Even if you never use it, at least you know about it. Okay, here's the key takeaways from the talk tonight. You gotta control the common mode current. It's so important to do that, and that's where chokes become essential. Right? The system approach matters. It matters the length of it, it matters how you install it, how you put up your antennas, and things like that. You can make simple changes to your existing system. You can use chokes, you can use noise filters, right? You can put up a different antenna. Right? Just follow the installation guidelines. Like I said, you know, all this whole talk on the website, as well as the helpful guides that are on the website that are free downloads. If you need help, just give us a call. The final thought that I have is every contact is a hand check between two antennas. Yours has got to be working right, and so is it. Well balanced and so make sure yours is the right one. It's installed the right way. If you understand the basics like I talked to you about tonight, you will have excellent results. Call us again if you have a problem. And we have, by the way, a specific download free for you. It's called OCF Antenna Confidence. It's about 40 pages of PDF file. It has all the graphs. It has everything you need to do in order to make OCF antennas, how to build them, what parts you need. You can buy the parts from us, you can buy the parts from anybody. These are the pieces that you need with all the dimensions for all the different band ranges. So I think hopefully we'll get some good use out of that. It's our top download that we have, is that particular one. And we're on the 5th edition, and we've had so many people ask to do extra things. Right, so very good, check it out. Okay, this is just a little blurb on those guides. It covers all sorts of different topics. I'm not going to spend a lot of time on it, other than the downloads are free. You got to give us your email address and send it to you. Other than that, there's no obligation. You don't have to spend any money. And you can download 4 or 5 at one time. You don't have to log in and do it every time. Okay. Now, if I was in front of you, I would give a little test time. Test time right now. I've got 5 real simple questions, and then I'll open it up for questions from you. And I'll be here as long as needed. Okay. Question number 1. What are the biggest problems?
Getting a little late. Can we skip to the Q&A?
Okay, let's do that.
Cool.
Let's go to Q&A.
Anybody have any questions for Bob?
That was good.
Okay, that's great. Thank you.
Everybody awake? Everybody awake?
I don't have a question, but I'd just say, Bob, your website has been a tremendous help to me over time. And
Well, great.
dug into a lot of it, so I'd recommend it to anyone.
Well, thank you very much. Go to the head of the class.
And the link to the PDF you mentioned is in my Sparks article this month. If you don't want to dig for it, it's right there for you. Thank you, Bob.
It's time for my dinner. I gotta go check into it that too.
All right, thank you.
All right, I appreciate it.